Welcome to Tegomatics. In this video, we are solving more problems on angles in parallel lines. If you're yet to watch the video where I introduce angles in parallel lines, you really need to do that. Just go down the comment section. The very first comment you see, there's a link there. Click on the link, it will take you there, because that video will give you an effective foundation into angles in parallel lines. If you're yet to subscribe to my channel, wow, this is another fantastic opportunity for you to do that. The word subscribe is written in red just below the video. Just click on it, subscribe to the channel so that you can get more of our notification. Turn on the notification bell, like the video, share it, and give a comment. I would love to reply your comment. In my last video, I introduced certain things to us about angles in parallel lines, and one of the important things we talked about were the different types of angles in parallel lines. We were able to identify corresponding angles, alternate angles, adjacent angles, vertically opposite angles, and co-interior angles. With those angles, we'll be solving more problems in this very video. So let's start with our very first problem, problem 1. So our first problem says, find the value of m and n in the diagram above. Find the value of m and n in the diagram above. If you look at the diagram, there are 3 parallel lines in the diagram. Don't forget, in my last video, I said to identify parallel line, most time or most cases, the arrow sign is always there. You can see the arrow sign. The first line is parallel to the second one, and the second is also parallel to the third. If you want to solve this kind of question, all you need to do is reproduce the line. Reproduce the line just like it is being done right now. You can see the first line is extending forward, the second line is extending backward, and the third line is also extending forward. So this will make our work easy. To solve this question, it will be very easy for me to insert a new angle. So I'm going to insert angle theta. You just have to, sometimes when you see this question, you just have to think, what can I do? What can I do? How do I find my m? How do I find my n? There should be a relationship between angle 125 degree and another angle before you move to the next angle. So I will insert my theta right there. Now there's a relationship between theta and 125 degree. You can see the z that is being drawn. Remember, I told you in my last video that to identify alternate angle, just draw a z. So this z will help us to find our theta. So theta is equal to 125 degree alternate angle. Now the next letter we need to find is our m. How do we look for m? If you observe the diagram carefully, you discover that there's a relationship between m and theta. And what is that relationship? It is called sum of angles on a straight line. You can see the line being drawn is a straight line showing the relationship between m and theta. So m plus theta is equal to 180 degree. And our theta is 125 degrees, so automatically m plus 125 degree is equal to 180 degree. M is equal to 180 degree minus 125 degree. So the value of our m is 55 degree. So finally, we need to look for the value of our n. How do we find our n? There is a relationship between our n and our m. I believe when you first saw the question, that was what came to your mind. Relationship between m and n. And that relationship is called alternate angle. But it's like, how do I find my n? How do I find my m? That is why we inserted the theta in the first place. So to find the value of our n, we just say n is equal to m, alternate angles. So automatically, n is equal to 55 degree. Very simple. Let's look at our next problem. This is problem 2. The question says, Find A, B, C, and D in the diagram above. Find A, B, C, and D in the diagram above. This question from the diagram, it seems kind of complicated, but it's one of the easiest questions we're going to solve today. Let's look at it. Let's start with our first letter, letter A. If you look at letter A, you discover that there is a relationship between letter A and 135 degrees. And what is that relationship? You can guess that already. Sum of angles on a straight line. So A plus 135 degrees is equal to 180 degrees. So A is equal to 180 degrees minus 135 degrees. So the value of our A is 45 degrees. Let's move to our next letter, letter B. If you consider letter B, you discover that there's a relationship between letter A and letter B. I know to some students this might be seeming complicated, and you might look at it right now that what's the relationship between A and B? That relationship is alternate angle. Check it. Alternate angle. Or do you want to reproduce the second line for it to be clearer? You can do that. If we reproduce the second line, it will be easy for us to draw our Z. Even without reproducing it, we can draw our Z, but to clear the confusion, you can reproduce the second line. So A is equal to B, that is alternate angle. Automatically, our B is equal to 45 degrees, because if A is 45 degrees and A is equal to B, then B is also 45 degrees. Let's move to our next letter. Letter C. How do we solve letter C? Okay, we could see that letter C is located on a particular angle. That angle is called reflex angle. If you want to know more about types of angles, you need to watch my very first video on geometry where I explain types of angles. You get more of reflex angle in that place. Now, C is located on the very reflex angle we could see there, and the relationship between C, letter B, and 16 degrees is called sum of angles at a point. And sum of angles at a point is equal to 360 degrees. A complete revolution gives us 360 degrees. So automatically we could say that B plus 16 degrees plus C is equal to 360 degrees. So 45 degrees, which is the value of our B, plus 16 plus C is equal to 360 degrees. So 45 degrees plus 16 degrees will give us 61 degrees. So 61 degrees plus C will give us 360 degrees. So the value of our C is 360 degrees minus 61. And C is equal to 299 degrees. Very simple. Now let's find our last letter, which is letter D. Now the letter D, what kind of relationship can I coin out here? Okay, look at the diagram very well. You notice that there's a relationship between 16 degrees and letter D. And what is that relationship called? It is called sum of co-interior angles. Don't forget, in the last video we said that the sum of co-interior angles is equal to 180 degrees, and you can easily identify it with a C. You know, just draw that C. Now if you draw that C, you could see that we have 16 degrees and we have D. So 16 degrees plus D is equal to 180 degrees. So the value of our D is 180 degrees minus 16 degrees, and our D is 164 degrees. That's very easy. Let's move to the next problem. This is problem 3. The question says calculate the values of angles marked with letters in the diagram above. Calculate the values of angles marked with letters in the diagram above. I love this diagram because me looking at it, I could see a triangle in the diagram. Okay, let me use this opportunity to talk about my video on polygon. If you're here to watch my video on polygon, especially the interior and exterior angle of a polygon, you need to do that. You get more information on triangle, and we're going to use that information in this video to solve this question. Now, the values of angles marked with letters. If you look at the diagram carefully, you discover that we only have two angles marked with letters, which is x degree and y degree. For me to find my x degree, I will reproduce the diagram by extending the second parallel line backward. The second one, I will extend it backward, and you might not extend it, but I love extending it so that everything will seem clear. Now, there's a relationship between x degree and a particular angle in the triangle. So I'm going to label that angle beta. So I'm labeling that angle beta. So there's a relationship between x degree and beta, and that relationship is called alternate angle. So before I can solve it, I need to first find my beta, which is the reason I said you need to watch my video on interior angle of a polygon. The sum of angles in a triangle is equal to 180 degrees. We are applying that here. Automatically, beta plus 54 degrees plus 39 degrees is equal to 180 degrees. You can see everything is in that triangle. Beta plus 54 degrees plus 39 degrees is 180 degrees. 54 degrees plus 39 degrees will give us 93 degrees. So beta plus 93 degrees, or we say 93 degrees plus beta, will give us 180 degrees. So beta is 180 degrees minus 93 degrees. So the value of beta is 87 degrees. Don't forget that we're not looking for beta. We inserted beta into the question, into the triangle, so that we can look for the value of x. So the relationship between x and beta is alternate. So we say that x is equal to beta, alternate angles. So if beta is 87, then our x is also equal to 87 degrees. So let's look for the other letter. Now, in the other letter, we could just go straight. There's a relationship between y degree and 39 degrees. That is sum of angles on a straight line. Y degree plus 39 degrees, sum of angles on a straight line. So the value of our y will now become y plus 39 degrees is equal to 180 degrees. So y is equal to 180 degrees minus 39 degrees. So the value of our y is equal to 141 degrees. So our x is 87 degrees and our y is 141 degrees. Let's move to the next problem. Now we have problem 4. Problem 4 says find the value of x in the diagram above. Find the value of x in the diagram above. Wow. If you look at this diagram, everything is just looking zigzag. You know? But we're gonna solve it. We're gonna solve it. Okay. If you look at the diagram carefully, the diagram is labeled P, Q, R, S, T, and U. Remember what I told you from the beginning, that questions like these must be reproduced. We have to reproduce them before we can what? We can answer them. If you observe carefully, it seems like there is a relationship between PQ and RS. it seems like there's a relationship between PQ and RS, and it's looking like alternate angle relationship. So if there's an alternate angle relationship between PQ and RS, automatically the angle that is there, the 50 degree, should be, that is angle PQR, should be equal to angle QRS. Check it. It's like a Z. Let me draw my Z. Let's put the Z there. That's like a Z. So it's like alternate angle relationship. But me looking at it, 50 degree is not the same as 86 degree. So it means that we need to reproduce a line there. So let's reproduce the line. So we'll reproduce another line. Let's label one of the end of the line N. N. So automatically we are having a relationship between PQ and RN. You can see that. We're having a relationship between PQ and RN. So angle PQR is equal to angle QRN. Can you see that? Which is 50 degree. So we could say that QRN is 50 degree. Now that we've gotten our QRN, we could also say that QRN plus NRS, that is angle QRN and angle NRS, is equal to 86 degree, because the whole of that part is 86 degree. So if QRN is 50 degree, what it implies is that NRS will be equal to 86 degree minus 50 degree. Can you see that? So our NRS is 36 degree. So we can just keep that. So we have a value for NRS. Just keep it. Let's go back to the diagram. Let's go back to the diagram. You see that we also have a relationship between the parallel line TU and the parallel line RS. That relationship is also looking like alternate angle relationship. If that be the case, 64 degree from UTS should be equal to X from RST. You see that? But that's not the case. How did I know that's not the case? Earlier we got angle NRS to be 36 degree. So the 36 degree for NRS should be having an alternate angle relationship somewhere. So if we reproduce another line, another parallel line from the diagram, maybe we insert a parallel line along angle S. So we'll split angle X into two. So when we split it into two like that, what it implies is that our angle UTS, which is 64 degree, will be equal to angle TSM. You know, the line we reproduced was labeled M. So our angle UTS will be equal to angle TSM. That's another alternate angle relationship. So TSM is equal to 64 degree. So we could see that the 64 degree is having a relationship with what? TSM. But the question says, find the value of X. How do we find our X? You could see that X is equal to angle RSM plus angle MST. Angle RSM plus angle MST. And what's our angle RSM? Our angle RSM can be obtained from a relationship between NRS and RSM. NRS is equal to RSM. That is angle NRS is equal to angle RSM, which is 36 degrees. So that takes us back to our X. So X now will be equal to 36 degrees plus 64 degrees, which gives us 100 degrees. This kind of question, you need to take it slowly. Thank you for watching this video. I hope you find it impactful. If you're yet to subscribe to my channel, in order for you to get notification of my videos, don't forget to subscribe. And remember to leave your comment. I would love to reply your comment. And don't forget to stay safe.